Hi, today we are going to solve some more examples on analyzing synchronous sequential circuits, and we start with the two problems that was assigned you as an assignment. So let's first solve the two problems from your homework, and if time allows we will solve more examples on analyzing sequential circuits. Okay, the first problem one from homework, says has two parts. Part A, find state table and state diagram. Part B, if input x is equal to 1 0 1 1 1 0 in this direction, and initial state y 1 0 y 2 0 is 1 1. It means that the outputs of both flip-flops are 1 at the initial state. Find z, and that's it. So, and of course we and also draw the timing diagram. Okay, here is the circuit. We have two flip-flops. The first flip-flop is JK flip-flop, J1, K1, output Q1 and Q1 bar. The second flip-flop is T flip-flop, so like it's flipped, so the inputs are on the right side and the outputs on the left side, so there is no like big deal, so we can just show in a flip-flop in any direction, so inputs can be in the left, output on the right, or input on the right and input on the left. Okay, so it's Q1 and Q2 and Q2 bar. Let's see how are the connections. J is connected to an AND gate. AND gate has two inputs. The first input is connected to the complement of X, which is input. The X, the input, goes to another AND gate and provides Z output. The other input of this AND gate coming from Q1, and T2 is connected to an XOR gate. This XOR gate has two inputs. One input is connected to Q1 and the other input is coming from Q2 bar, and the Q2 is connected to the second input of the first AND gate, and finally K1 is connected to X. That's it. Okay, this one is the circuit, and of course we need to have a common clock signal for both flip-flops. Which is common clock, and we want to analyze this circuit. As you remember, I mentioned that we start by labeling the outputs and also finding the functions of each combinational circuit or each gate. So let's do that. So first thing we say, we can say that Q1 is Y1, Q bar 1 is Y2, Y1 bar, current state, Q2 is Y2, and Q2 bar is Y2 bar. And the second thing we should do after labeling the outputs with the name of Y instead of Q, we need to find the outputs of or determine the outputs of each gate. So of course for the AND gate, we for the first AND gate on the left, we will have X bar and Y2, Y2. X by Y2, the output Z is equal to X, XY1, XY1. The output of XOR gate, of course, is Y1, XOR Y2 bar, XOR Y2 bar. Okay, so these are the inputs, so we can say J1 is X bar Y2, K1 is X, and T is Y1 XOR Y2 bar. So we just got these three important equations as well as Z, which is equal to X, Y1, these four. So these four functions are very important for us in order to solve the problem. Okay. Now, what's the next step? Because we have two flip-flops, no matter what kind of flip-flops. Because we have two flip-flops, we need to do two uh, state tables for any individual flip-flop. So one state table for each flip-flop, one state table for the output, and then combine these three state tables. So first, let's start from flip-flop number one, which is JK flip-flop. Okay, so for JK flip-flop, for the JK flip-flop, we draw the table. The table has four rows because we have two flip-flops and four different states. So we draw this state here. Okay. We have input X and output, present states Y1, Y2. Y1, Y2. Present state. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Let me copy this table because we will need this table for the other flip-flop as well. So copy, paste. Let me just copy it. Copy, paste. It's not working. One more time. Copy, paste. Okay, finally. And one more, paste. Okay, so we have these three tables. So the first table is for next state of flip-flop 1, which we call it capital Y1. Okay, let's see how we can find the value of different cells in these flip-flops. So one thing that I want to do here, it's like a way that helps us to write JKs for each flip-flop. So what is J? J is J is X bar Y2 and K is X or J1 K1. And because this one is for Y1, next of Y1, let me just change the color of present states of Y1. It helps. And in this inside this table, I solve it in this way. I would say J1 is equal to J1. Let me change the thickness of my pen. Okay. J1 is equal to K1 is equal to. Okay, J1 is equal to X bar Y2. What is X bar for this cell? Of course, X bar is 1. What is Y2? Y2 is 0. So X bar Y2 is 0. So J is 0. J1 is 0. What about K1? K1 is 0. For the next state, again, for this cell, J is X bar is 0, of course, because X is 1. So J is 0 and K is 1. Okay? So let's complete J and K for all these cells. For this cell, J is Y2 is 1, J X bar is 1, so J is 1. What is K? K is equal to X, which is 0. For the other cell, J is 0. What about K? K is 1. For the other cell, for the next cell, J is 1. K is 0. For the next cell, of course, J is 0. K is 1. For the next cell, J is 0. K is 0. For the last cell, J is, of course, X bar is 0 and K is 1. Okay, so when we got to this point, the rest is easy. Of course, for the first cell, I'm talking about this cell. J0, K0, no change. No change of what? No change of Y1 because we're talking about Y1. So what is Y value of Y1? Value of y1 is 0, so no change means 0. J0 K1 means reset, so 0. J1 K0 means reset. J0 K1 means reset. J1 K0 means set. J0 K1 means reset. J0, K0 means no change. What is the value of Y1 is 1, so it will be 1. Finally, J1, J0 and K1 means reset. So we completed the first cell, okay? First table. So the first table is done. Let's move to the second table. The second table is for Y2 and this one is a T flip-flop. Let's just see what is T. T is equal to, of course, y1 x or y2 bar. Okay, so um, we can say T for the first cell is equal to y1 is 0, y1 is 0, y2 bar is 1, so 0 and 1 xor means 1. T for the next cell, again the same thing, because they are in the same row, and there are if you see, the T is regardless independent from the X, so it only depends to Y1 and Y2. The second cell, what about T? Y1 is 0, Y2 bar is 0, so X or 0 and 0 means 0. The next one also 0. The third row, Y1 is 1, Y2 bar is 0, and XOR is 1. So 1, 1. The last row, Y1 is 1, Y2 bar is 1, 1 XOR 1 gives 0. So T is 0. Okay, now what about the value of Y2, capital Y2 in this table? Okay, we know that T equals 0 means no change. T equal 1 means complement. This is how a T flip-flop works. So which value should be considered? Because it's Y2, let's change the colors of Y2. These are red colors. So T is 1 for the first cell, Y2 should be complemented, so it's 1. The next one is 1. T is 0, Y2 no change. T is 1, Y2 should be complemented. T is 0, Y2 no change. Okay, you see how easy we fill the table. Of course, it's not very difficult, and a T flip-flop or D flip-flop is easier than JK flip-flop because we have only one input and we can easily find the output. Okay, now that we got Y2, it's time to find Z. Z is equal to X Y1. Okay, so this one is the easiest part. X Y1. So as long as X is in the first column, X is 0, of course Z will be 0. And if X is 1 and Y1 is 1, the output will be 1. So X is 1 and Y1 is 1, output is 1. For the other values, output is 0. So if we look all these two tables together, we see that we got the individual, not two tables, sorry, state table. We got the individual state tables for all three variables, and it's time to combine these three tables together. Okay, so in order to combine them, let's just paste the complete table. Okay, and we can just take these values, this one, this one, this one, and put it here. Okay, and the next one, this one, this one, this one, for example, put it here. Okay, so these are the truth table. And if we not truth table, I don't know why I keep saying truth table, state table. So let's combine them. So it's 0 1 0 0 1 0 1 1 0 0 1 0 1 0 0 0 0 1 1 0 0 0 0 1. Okay, and so this one is y1 y2 over z. Now I have a question. Is it like a milli model, or Moore model. If we look, we see the Moore model says that we have the same output for each state. So the outputs are not dependent to the inputs. But if we look here, we see that for example, in third state and fourth state, the output is dependent to the input. So definitely this one is a mini model, not Moore model. And from here we do assignments, symbol assignments, and we say A is 0 0, B is 0 1, C is 1 1, and D is 1 0. And now we can easily excuse me, we can easily convert this table to a form of alphabetic symbols for states, so A, B, C, D, state A, state B, state C, state D, and we can substitute the values, the binary values in the cells with A, B, C, D. So we will have B0, B0, C0, B0, D0, A1, D0, and A1. And this one in fact is next state, and in the denominator we will have output. So this one is the complete state table, and from a state table we can easily draw the state diagram because we have four states. Let's see, have four circles, A, B, C, D. No matter if you change the order of A, B, C, D, so you can just put B here, C here, no matter, like the answer is same. So we complete this table based on this diagram based on the table. For example, if we are in a state A and the input is 0, we go to a state B and the output is 0. If we are in A, input is 1, we go to B and output is 0. So we have, in anyway, like in both regardless of the input, we move to the state B, and the only thing and the output is of course 0. If we are in a state B, input is 0, we move to state C and the output will be 0. If we are in B and the input is 1, we remain in state B and the output is 0. If we are in state C, input is 0, we move to state D, and we move to state D and the output is 0. If we are in C and input is 1, we move to state A and the output is 1. If we are in a state D, input is 0, there is no change and output is 0. And if the system is in state D and input is 1, the state changes to state A and the output will be 1. So this one is the state diagram for this example. Now it's time to draw the timing diagram and calculate or find the output z as a function of input x. Okay, so let's do that. Okay, the first thing we should define is clock cycle. So here is clock, 1 clock, 2, 3, 4, 5, 6. Why 6? Because we have 6 inputs. So 60, like the input, let me show you. The input here is 6, 1, 2, 3, yeah, 6 bits. Okay, so clock number 0, 1, 2, 3, 4, 5, 6. Okay, input X, next state Y1, next state Y2, J1, K1, T2, and Z. Okay, so these are the variables we want to find. And then let's just show the rising edges. Just mark them because we need to have these edges for change, for applying any change to the signals. Okay, these are like edges. And input, what was the input? If we look to the input, input is we read it from right to the left, so it's 0 1 1 1 0 1. So let's just insert the x. So x starts from 0 with a little delay, propagation delay. We should consider this delay for all timing diagram. So 1, 2, and 3 clock cycles has a value of 1. Then it becomes 0 for 1 clock cycle. Then changes again to 1. And after that 1. Yes, 3, 4, 5, 6. That's enough. See, we go up to this point. Okay, so the next thing is J1. J1 was equal to X bar Y2, and K1 is equal to X, and T is equal to Y1 XOR Y2 bar, and Z is equal to X Y1. Okay, so let's go ahead and complete this diagram. Okay, we'll start from y1 states, from the initial states. So we know that the initial states, if we look to the problem, it says that the initial states is 1 1. So both give me a second. Okay, initial state starts from 1, so y1 is equal to 1, and y2 also is equal to 1. Now that we have these two initial states, we need to find J1, K1, and T2 and Z. Okay, so J1 is X bar Y2. X bar Y2 because X bar is 1 and Y2 is 1. So J will be 1. What about K1? K1 is equal to X, which is equal to 0. What about T2? T2 is Y1 X or Y2 bar. Y1 is 1, Y2 bar is 0, so T2 also is equal to 1. What about Z? Z is X, Y1. X is 0, Y1 is 1, so it's 0. Okay. Now that we reached to this point, using J1 and K1, using J1 and K1, we determine the next state of Y1. J1 is 1, K1 is 0, it means set. So next state will be 1. What about Y2? T2, T2 is 1. It determines Y2. 1 means complement for T flip-flop. Y2 is 1, so it will be complemented to 0. Now that we have the new Y1 new states, we can determine the updated values for J1, K1, T2, and Z. What about J1? J1 is X bar. X is 1 at this moment. Of course, X bar is 0, so J will be changed to 0. What about K? K is 1. What about T2? T2 is X1, Y1, X or Y2 bar, which of course is 0. And what about Z? Z is X, Y1. X is 1, Y1 is 1, so X changes to 1. Z, sorry. Z changes to 1. Now again, using these two values, let me change the color to green. Using these two values, we determine the next state of Y1. Okay, so it's 0, 1. 0, 1 means reset, so Y1 will be reset to 0. What about Y2? Y2 is determined by T2. T2 is 0, means no change, so Y2 is 0. Now that we got Y1 and Y2, it's time to like it's time to move to determine J1, K1, T2. So J1 is X bar. X is 1, so X bar is 0, so J1 of course will be 0. What about K1? K1 is X, which is 1. Okay. And what about T? T2? T2 is Y1, Y2 bar. Y1 is 0, Y2 bar is 1. So 0 and 1 gives T2 of 1. So T2 changes to 1. What about Z? Z is X, Y1. X is 1, Y1 is 0. So TZ is 0. Okay, then again we continue the same story. 0 and 1 results in reset, so it's y1 is 0, and on the other hand t2 is 1, it means complement, so y2 will be changed to 1 like this. And now again we continue to find J1. J1 is X bar, X is 1, so X bar is 0, so J1 will remain 0. What about K1? K1 is equal to X, which is 1, so K1 is 1. What about T2? T2 is Y1 X or Y2 bar, Y1 is 0, Y2 bar is 0, 0 and 0, XOR is 0, so T2 will be 0. What about Z? Z is X, Y1, X is 1, Y1 is 0, so Z also will be 0. Next state, 0 and 1. Again, 0 and 1 means reset, so Y1 still is 0. Y2, from here, it's T2 is 0, so Y2 no change, it is 1, so it remains 1. Then again continue to calculate J1. J1 is X bar, X this time is 0, so X bar is 1. Y2 is 1, so X bar Y2 is 1. So J1 at this moment will be switched to 1. So J1 will be 1. What about K1? K1 will be switched to 0 because X is 0. What about T2? T2 of course is 0. And what about Z? Z also is 0. Again, let's continue. This time 1 0. 1 0 means set. So at this moment, y1 will be changed to 1, and y2 based on the value of t2, which is 0, means no change. Also y2 will remain 1, and time to find j1. J1 is x bar, x is 1, so x bar is 0, so j1 will be switched to 0. What about K1? K1 is 1 because X is 1. And T2 is equal to 1. T2 is equal to 1. Okay. And of course, Z, which is X, Y1 will be equal to 1. Will be equal to 1. And we stop at this moment because we don't have no input anymore, so we stop at this clock, and we can say z is 1 0 0 0 1 0 in this direction, and this one is the output. Okay, so we solved the first problem of the homework, and you see that how we start from the initial situations and based on the information given to us uh, in the problem, we analyzed the circuit. Okay, so next let's move to the second problem of the homework and try to solve that circuit. Okay, so let me check if it's recording. Yes, it is. Good. Okay, problem number 2. From the homework, part A, state table and state diagram. Part B, if input x is 101100 and y1 y2 are equal to 0 1, find the z and timing diagram. Okay, here is the circuit. Let me draw the circuit. We have two flip-flops, J1, K1, Q1, Q1 bar, J2, K2, Q2, Q2 bar. Output is Z and K1 is connected to AND gate. The AND gate is connected to input X. J2 is connected to X bar. K2 is connected to XOR gate. The first input of XOR gate is connected to X. The second input of XOR gate is connected to Q1 and Q2 is connected to second input of this AND gate and also J1. That's it. So this one is the circuit, and of course we have the clock cycles. Clock, which is connected to both inputs. Okay, as usual, we know what we need to do. We need to define, label the outputs. So outputs are y1, y1 bar, and y2. And the output of each gate, the output of AND gate is x bar y1, and the XOR gate is x XOR y1. Okay, that's it. Yes, easy. So J1 is equal to y2. K1 is equal to x bar y1. J2 is equal to x bar, and K2 is equal to x XOR y1, and Z is equal to y1 bar. That's it. So we got this information, and based on this information we can solve the problem. So from entire this circuit, what we need to know is just these relationships. So when we got it to this point, we even don't need to look to this circuit anymore. Okay, so we have all information we need. All information we need are here. Okay, so let's start by those tables and solve the problem. So again, paste this table here for y1, and as I mentioned, uh, we know that j1 is equal to y2 and k1 is equal to x bar y2, so we can easily fill this table. So if I change the thickness of my green pen, so we can say j1 is equal, k1 is equal, j1 is equal to y2. So let's just change the color of y1 here, y1. Okay, so j1 is equal to y2. y2 here is 0. What is k1? k1 is y2 x bar, which also is equal to 0. If we write these j's and k's for all different cells, we will have 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 0, 0, and of course 0, 0. Okay, so we know that 0, 0 means no change, 1, 1 means complement, 1, 0 means set, and 0, 1 means reset. So 0, 0 means no change, so 0. 0, 0 means no change, 0. 1, 1 means complement, 1. 1, 0 means set, 1. 1, 1 means complement, 0. 1, 0 means set, 1. 0, 0 means no change, 1. 0, 0 means no change, 1. Okay, so we have the first table completed. The second table, J2 is X bar and K2 is X XOR Y1. And this one is for Y2. So let's change the color of Y2. And the same story, J2, K2. J2 is X bar, X is 0, so X bar is 1. K2 is X XOR Y1. Y1 is 0, X is 0, so XOR is 0. So if we complete the entire cells like this, we will have 0, 1, 1, 0, 0, 1, 1, 1, 0, 1, 0, 0. For the last one, let's do it together. So J is equal to X bar, X is 0, so X bar is 1. K is X XOR Y1, X is 0, Y1 is 1. So 1 and 0 XOR gives 1. And the last cell here, J2 is X bar, which is 0. K2 is X, which is 1. Y1 is 1. 1 XOR 1 is 0. And now we just complete this table. So 1, 0 means set, 0, 1 means reset, 1, 0 means set, 0, 1 means reset, 1, 1 means complement. Complement of what? Complement of y2. So means 0, 0 0 means no change, no change of y2. 1 1 means complement of y2, which is 1. 0 0 means no change, so it's 0. So this one is the second table. Let's move to the third table, which is the output. So let's just paste the table here. Okay, for the output, for oh, it changed the color. Nice. I didn't know that I can change the entire like color by selecting the color. Okay, Z. So and we know that Z is equal to Y1 bar. So this one is very easy. So Y1 bar. What is Y1? Y1 is like the first digit here. So we just complement it and place in the table. So 1 1 1 1 0 0 0 0. That's it. So this one is the state table for the output. Okay. Now we combine these three tables together and build a new table. Yes, we can change the color. Okay, fine. And we just get the values from each cell. For example, this cell, these three cells, and put it here. Okay, so we combine all of them. By the way, should we go with milli model or more model? If it doesn't ask you to specifically draw the table based on milli model or more model, usually we go with milli model because milli model like has both conditions. More model can be implemented by milli model as well. Okay, so let's fill this table. So it is 0 1 1 0 1 over 1 0 0 1 1 1 1 1 0 1 0 0 0 1 1 0 1 1 0 and 1 0 0. And in the next step we do assignments. A is 0 0, B is 0 1, C is 1 1, and D is 1 0. And this time for the states we use A, B, C, D instead of binary values. So it is B over 1, A1, C1, D1, A0, C0, C0, D0. Okay, so this one is the state table. If we go by drawing the state diagram, A, B, C, D. If we are in A, input is 0, we move to B and output is 1. If we are in A, input is 1, the state doesn't change and the output is 1. If the state is B and input is 0, it changes to C and the output will be 1. If state B and the input is 1, changes to D and the output will be 1. If state is C, input is 0, the state changes to A and the output will be 0. If state C and input is 1, no state change and output is 0. And finally, if we are in a state D, input is 0, it changes to C, output is 0. And if the state is D and if a state is D and input is 1, it remains in the state D and the output is 0. Okay. Okay, and the next step is like drawing the timing diagram for this example. For the timing diagram, we start by drawing the clock cycle. 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5. We have X, we have Y1, we have Y2, J1, which is equal to Y2, K1, which is equal to X bar Y2, J2, which is equal to X bar, K2, which is equal to X or Y1, and finally Z is equal to Y1 bar. The rising edges are being marked. Okay, the input is 0, 0, 1, 1, 0, and 1. Y1 starts from 0, Y2 starts from 1, and if based on these values we determine J1, K1, J2, K2, and Z, we will have J1 equal to 1, J2, K1 is equal to 1, J2 is equal to 1, K2 is equal to 0, and input is equal to Y1 bar. Y1 bar is 1. Okay, so if we complete, I just draw the entire answer, so I don't like move step by step because we know how to do that, but the answer is here. You can compare this answer with your solution. Okay, y2 y2 is 1 1 J1 is 1 1. K1 is like we know that we cannot just do it as I'm doing, like what I'm doing, because I'm just writing you the whole answer. We need to move step by step. So from these two we need to find this four information. From this four information move to the next step, and back and forth, and find the complete entire entire diagram. But here I'm just trying to show you the whole answer. So y 0, 0, 0, 1, 0. K2 is 1, 1, 1, 0, 1, 0, 1, and 1, 1, 1, 1. Okay, and so this one is the final answer, and Z is 1, 1, 1, 1, 0, 1. So this one is the solution of problem 2 of the homework. Okay, in the next lecture I will continue with some more examples.